of the symposium. This session titled Building AI Talent for the Knowledge Economy will be moderated by Professor Mehmet Akif Kireççi. We kindly invite him to the stage. The session will focus on AI literacy, micro-credentials, large language models, AI infrastructure, accreditation, and quality assurance in higher education.
Okay, good afternoon, dear participants. We are about to start the last session of today's program. The title of this session is Building AI Talent for the Knowledge Economy. Our presenters will provide different perspectives and they are all coming from different backgrounds. I hope this will enrich the content of the program. Our first presenter is Professor Dr. Arası Bozkurt. He is a researcher and faculty member at Anadolu University. With MI and PhD degrees in distance education, Dr. Bozkurt's work focuses on empirical studies in areas such as distance education, online learning, network learning, and educational technology. The title of his presentation is Upskilling the Future, Bridging the AI Literacy and Micro-Credentials. The floor is yours, Professor Arası Bozkurt.
Okay, this is sound check. Hello everyone. I'm really pleased to be among you and talk about the trending topic of the higher education, AI. I will make a brief presentation which will focus on AI, higher education, and micro-credentials. So I just would like to start briefly introducing myself. I am the Dean of Open Education Faculty. We have 1.5 million students, and we heavily use education technology, including AI. And last week, somebody asked me, how do you manage, a faculty with 1.5 million students? I just told them, rather than recruiting, skilled scholars or administrative staff, we are now using AI agents. There is a change, and I am very aware of this change, and I benefit from this change in a post-digital era. Saying post-digital era, I would like to emphasize that we are not in a digital era, but we are in a post-digital era. That means in this era, we hear that AI is a revolution, but what does that mean for the average worker? That means shelf life of the knowledge is shrinking. In the past, a university degree was like a passport. It was valid for 30 years of travel in your lifelong learning career. Today, because of the growth of the AI, this passport expires much faster. Traditional education is like a large ship, but it is stable. On the other hand, it turns very slowly. The market, however, is like a speedboat. It changes direction every month. To survive, we need to bridge the gap between a stable ship of degrees and the speedboat of the industry. Another thing, 10 or 20 years ago, having a university degree, it was kind of a granted visa for everything. But now we realize that whichever university you graduate from, whatever skills you have, even 1 week later, your knowledge, your expertise can be obsolete. So in such a time when the AI is dominant technology and affecting higher education, we can use AI literacy as a solution. Indeed, literacy is not about how to use, but it is about how to think. let's define the AI literacy together. Many people think AI literacy means knowing how to open a chatbot. This is only the surface. Many people use, large language models like using Google, so they don't really benefit from this technology. On the other hand, if I summarize AI literacy, it has three foundational ideas. You should have the background about know what. That means you have to know what is AI, what's the origin of AI, or you need to know the basic definitions about the AI. The second component, the second pillar is know-how. You have that technology, but you have to know how to use this technology effectively. And most importantly, you have to have some background about know why. Know why is mostly about responsible, trustworthy, and ethical use of AI and having full awareness of the AI. When we compare these three pillars, I can say that know why is really important because the know why dimension makes the distinction being a consumer or user. If you don't have sufficient background about know why, you are a consumer and indeed you are not controlling the AI technologies. On the other hand, AI is controlling you. And if you don't want to consumer but user, you have to have these backgrounds. Having these backgrounds, having a degree of AI literacy means that being the architecture of the future in your personal or professional life. The other issue is the micro-credentials. In a time when the AI technologies are dominant and AI literacy important, why micro-credentials? This is the questions we are trying to answer in this session. Indeed, micro-credentials are security patches for human capital because even if you have the AI literacy, we have to deliver that to a large population of the people. I mean, these can be workers, students, or anybody in the market. On the other hand, if you want to update people, you could not tell them, okay, now we are living in a post-digital age, you need to go back to the university. You have 4 years more, you have to update yourself. This is nearly impossible. In such a case, micro-credentials appear as a working solution because people can continue their routines, their lives, and while they are doing that, they can update themselves by using micro-credentials. What are micro-credentials? They are indeed small, verifiable, transferable, and collectible units of learning. Think about your smartphone. You don't buy a new phone every time. You want a new feature. Indeed, what you do is to update your software. So micro-credentials are kind of updates for humankind and human experience. They are bite-sized, verifiable, and flexible. Approaching from these perspectives and realizing its importance, 10 days later we will announce the biggest micro-credential project in Turkish higher education at Anadolu University, and we are planning to deliver this kind of micro-credentials to our on-site face-to-face students and online students. So indeed, this is kind of a countdown for me. The other issue is about personalization and resilience. Indeed, moving from just-in-case to just-in-time learning is now happening. When we combine AI literacy with micro-credentials, we create a data-driven engine for careers. In the old system, we use just-in-case education. We learn things just in case we need them in 10 years. In the new system, in post-digital era, we use just-in-time education. AI can actually help us here. AI can look at our experience, background, even check our CVs, the need from the job market, and it can say, hey Aras, you are a professor, but you need a micro-credential about, let's say, blockchain. It is personalized pathway. And to update myself on blockchain, I don't need to go back to the university. Indeed, I can just enroll a 4 weeks micro-credential course. I can enter an exam, I can verify it, and I can take this skill to my e-portfolio or digital wallet. And the exciting part is that, in traditional universities, everything is scheduled. When you enroll a program in an higher education institution, the courses, the paths, even the events you will attend are already scheduled. But with micro-credentials, consider it like a Lego. You can select the skills and competencies you need. You can take them and you can build your own learning pathway. So this is really exciting. And approaching from this perspective, I don't see micro-credentials as an emerging term or as a trend forced by rapid change in higher education. Indeed, I see it kind of a skill for resilience, being resilient in post-digital age. In short, I can tell that lifelong learning is no longer a luxury. It is a necessity for survival in a post-digital age. So we need a bridge to survive in post-digital age when the generative AI and agentic AI influencing every dimension of our life. And we need to keep ourselves updated, and micro-credentials currently looks as a working solution, and it looks like a bridge between higher education and the industry. So with micro-credentials, what we do is not delivering educational content, but indeed empowering the learners, workforce or other professions. Thank you. This was end of my presentation.
Thank you very much, Hocam, for this timely and... Okay.
Thank you very much.
Yes. The next speaker is Professor Mirjana Ivanovic, coming from Serbia. She's a full professor at the Faculty of Sciences, University of Novi Sad, corresponding member of the Serbian Academy of Sciences and Arts since 2024. The title of her presentation is Integration of Large Language Models in Intelligent Tutoring System, Adoption and Ethical Aspects.
Okay, thank you. First of all, as all other participants, I would like to thank organizers to inviting a representative of Serbian Academy of Science and Arts, and they delegated me. Unfortunately, I did not know in advance how presentation will last, so I prepared a lot of slides. So I will change some dynamics and presentation. So also the title is a bit different than expecting. So we all of us know that artificial intelligence has different phases during the history, starting from first publishing books through radios to first learning management systems and so on, and nowadays to remote learning. Sorry. So history of intelligent tutoring systems, which are the main point in this presentation, started in 60s and 70s last century, constantly improving and incorporating different AI approaches, so including machine learning, natural language processing, recommendation systems, and so on. So in last stage, let's say we are witnesses of enormous rapid development of generative AI, large language models, and so on. What I would like to tell here, in fact, I would like to concentrate to our intelligent tutoring system, because my background is in fact computer science, programming languages, and technology-enhanced learning. And we developed one intelligent tutoring system which evolved through different phases, including different approaches, of course, getting more and more intelligence and more personalized, but also arising questions about ethical issues, for example, very important data privacy of students during the educational processes using intelligent tutoring system. And in some phase, we also introduced learning analytics. So from that point of view, ethical issues started to be very important, and also some of fairness issues, which I tell something about it later. So, what is the main focus? And the main focus is our Protus intelligent tutoring system, which was developed, starting to be developing maybe more than 15 years ago. But at that moment, we employed elements of recommendation systems and collaborative tagging techniques, and also changed different approaches, and also include association rule mining techniques which predict behavior of learners, and according to that, suggested them topics and learning paths. We use the learning style identification approach as a cold start for our participants in that experiments. Maybe it is a bit out of date from point of view of some researchers, but still learning styles are our approach, which is used in such systems, and based on learning styles, we make different groups of participants according to information processing, perception, reception, and understanding. So our system was mainly used in experiments, and in a big experiment we included more than 300 undergraduate students, and because our system was developed to be general, it means that it could be applied for different topics and in different areas, but we focused on the teaching introduction of programming language Java, and for that we performed experiments with 340 students at my faculty. Here is a structure of system, I will not go into details, but on the left-hand side you can see a rather complex interface which use students to communicate with the central system, which includes a learning module, adaptation module, domain module, analyzer, and so on, which all together helped students to select, to propose topics, but also on the other hand, they are of great help for teachers and preparation teaching material and improving teaching material based on students' results. Of course, our system includes topics, tests, small programming examples, and different kinds of examples and tests. You can see here on the left-hand side the visual presentation of 4 statements, and for students who are more textually oriented based on learning style, it is the same topic in textual form. As I said, we try to improve our system, so in meanwhile we experimented with different aspects like taste and smells with students using different tastes like chocolate, coffee, and so on, but it was small experiment. We also included eye trackers in that system to conclude about students learning based on eye tracking during learning particular topics. And one of the most important enhancements of this system was use of mastery grids, which was a component developed with Professor Peter Brusilovsky from Pittsburgh University, and which is in fact one social component for teaching and learning different programming languages. So it is some simplified version where a student can see his position comparing to other participants in teaching. So if he or she look at and learn one lesson and his mark is yellow, it means that he is better or she is better than group, average success of group, and blue means that it is worse, he is worse than average of group. So based on that, we collected also a lot of information from students who use that system and produce some results and publish some results, but it is another aspect of story. What is interesting from our point of view, it is that again, maybe more than 10 years ago, before generative AI get widely used, we proposed also extension of our system, including two kinds of pedagogical agents, one helpful and one leading. What was the main idea? The main idea was that students who solve some small programming problem missed some parts of solution, and they need to enter that part. And they could use support of agent, and at the moment when agents suggest them a part of code which should be included in solution, the student is not sure whether is it useful or misleading agent. So the main idea was to push students to think critically, not to accept blindly information they got from agents. It is some initial version, I would say, of today's programming stage in programming, where we have extensive use of AI coding and the possibilities that a system can suggest students or programmers or software developers to suggest appropriate parts of code. So it is, I would say, the similar idea or the same idea, but of course nowadays generative AI can help more than our initial agent system and agent support. And it is interesting, of course, that there are some different stories and, for example, some series which compares productivity of human software engineers and AI-based software, let's say, chatbot developers. And it also could be one interesting idea for us to continue or to renew our system according to current state of development in this area. Of course, you can see here on that picture different possibilities and different challenges for developing intelligent tutoring systems. First of all, from our developing educational systems and generally educational environments, and for our point of view, it's interesting, again, personalization, highly tailored material to students. And we plan for some future to continue with this development, but it is very important and challenging two questions, adoption and fairness of such useful and misleading agents, and also some ethical aspects connected to privacy and private aspects. Sorry that I ran through slides and was too fast.
Thank you very much. Okay, now I would like to invite Professor Özcan Öztürk of Sabancı University. He has been a faculty member at Sabancı University since February 2024. His research interests are in the areas of parallel computing, hardware accelerators, quantum computing, process design, and heterogeneous architectures. The title of his talk is The AI Infrastructure Landscape.
All right. Thank you for the introduction. Hello, everyone. I'm going to talk about a different topic than what has been presented so far. So I'm personally a computer architect, so mainly I do design hardware for parallel applications and data-intensive domains. And AI is obviously an important area for us to cover these basics. I will try to explain what's the current status and then where the world is going, so that we have a better idea about what hardware platforms are needed for future generation AI systems that is inevitable. As mentioned by Mehmet Kemal Hocam here, before AI has been there for many years for many of the computer engineers
probably in the room. So we already have been teaching this artificial intelligence courses in computer engineering curriculum, but the specific interest has been increased due to generative AI. As you can see from this slide, it is just a subset of the whole AI, infrastructure. And the key change about AI is, this doesn't work? No? Okay. It works. So the key change in AI is actually AI is moving from talking to us to working for us. With the change and shift, as I will mention shortly, AI is now working as agents to support the users in their AI needs. One key aspect of AI infrastructure that's currently working, generative AI, is actually that creates the content, text, and response chatbots and whatnot, is kind of extending to agentic AI. So we have agents, AI agents that work for us. So they do independent planning, reasoning, tool integration, and many other supportive features exist with the newer generations of AI workflow, as I will show some of the examples of the most recent AI frameworks. So among this, many of the software engineers right now use these agent tools for their development. And they, for example, design an agent that detects the debug in a software, and then another agent that is going to find out what's the problem, another agent to actually solve the problem, and a fourth one, for example, to test it out. So you have agents that work for you in an agent manner, and agentic AI is kind of the new trend that is widely used in many of the industry here. And I just wanted to briefly give you an overview of what has been there for the AI infrastructures, AI models that are out there with their parameter sizes. So I would like to emphasize the increase in the number of parameters that is used for training these AI tools. And that is actually a significant part of the whole AI infrastructure world. Because as the number of parameters increase, that means you're going to have to invest a lot more in the hardware to train those. And as you can see, you have 10,000 billion, which is actually trillion parameters that is going to be part of the latest versions of the AI frameworks. So that's a huge number of parameters that you need to deal with, which means you need a lot of hardware, a lot of support to compute all of this. So this actually can be also seen in a chart like this. This is a log chart, so it's not a linear chart. So it's every step is 10 times more the other one, log scale, which is actually indicating the impact and the increase, the dramatic increase in the number of parameters that you're dealing with. So with the GPT-4, actually we have the parameter scaling. Now we have a change in the AI infrastructure, AI models that we deal with, which is the mixture of experts. Starting with that, now we have actually multiple experts that you have as part of the whole AI framework. So this is a shift from the original generative AI, where you have option to choose which part of the track you want to take. So you could go either this way, that way, or another one according to the expertise that's needed for the AI question, AI problem that you're dealing with. And then also, we also have computed inference, test time compute, so you actually have additional support while the request is being made for the AI, so that you have actually a smaller model which may actually answer in a better fashion than a complex model that is being trained. So computed inference during inference stage is also a new era optimization that is out there, so we also need to consider that. And newer models that are being implemented also try to address not only the cost of giving an answer to you, but also how well the answer, how well the solution was from a user's perspective. So now the new trend is actually making sure you get actually good results as the requests come into the to the AI libraries. So the giants exist in models, right? We have GPT, the latest one is 5.5, and Cloud 4.7. And the training scale for these, I would like to emphasize this, critically, because this is an important factor. If you look at the numbers here, we see that there are, clusters that are needed to support these in the orders of 180,000 to 250,000 GPUs, which is a huge number. So we're not just talking about hundreds or thousands. This is close to 100,000 numbers, which is a huge number. And the hardware standard needed to support these these models is actually also very expensive. So I will give some numbers about the cost of this implementation and the infrastructure shortly. But what is out there is actually an important infrastructure that you invest, which is going to cost you a lot. And that means you will also need to consider the new metrics along the lines of giving good answers. So cost per token, how much you actually invest into this, and then inference efficiency, how efficiently you answer the request, whether you need to do multiple iterations to respond to the user, because that means a cost to the whole system. So that's why we need to consider the whole framework when we are discussing about the pros and cons of the designs. So there are technical limitations in addition to the ones that is being discussed so far. Social limitations and concerns exist. I will also briefly touch upon that, but technical limitations and concerns are critical. Also, some of these are mentioned before. Data scarcity is one key limitation. Because the human-generated data is almost exhausted, so more data is needed, which means you need to somehow generate them. And if this is done in in an AI manner, if the AI creates its own data itself in a synthetic manner, that's going to create actually model collapses potentially in the future. So this is one technical limitation people are trying to, or researchers are trying to address. Another one is power constraints. Again, this has been also mentioned in one of the presenters' presentation before. So we have actually a lot of power that needs to go into these servers, these data centers, and you need to also consider the grid instability. So this may affect the other users of electricity, right? Because a lot of people use the same electricity, and if these AI infrastructures consume a lot of power, then it may affect the users in households. And then also another problem that we need to consider is the reliability of these models, right? As we all know, again mentioned briefly before, hallucinations exist in these models, so they use statistical patterns, not facts. So that's going to be a critical limitation that we need to consider. So the reliability remains as a concern to consider. I have a small set of social implications, which I'm not going to go into details. One is safety, so harmful content may be there, and then the other one is job displacement, so you may actually lost some of the jobs out there, hopefully generating new ones, but that's definitely an issue there. And then real versus fabricated is a concern, but the last one is the one that I want to emphasize, aside from the ones that has been discussed before in this room. That one is actually unforeseen risks may exist because you now have agents that are doing tasks for you. Before a human can intervene in a problem, these agents may actually have already done the harmful acts so far. So this is another dimension that needs to be considered as a social impact of the AI infrastructures out there. Now, I would like to consider or talk about the CAPEX explosion, which is the kind of 1 billion threshold, and that goes into these AI infrastructures. So if you want to create a hardware infrastructure that's going to implement a model, a big size model, then you have to invest $1 billion in hardware procurement mostly, in buying the GPUs, buying the equipment that's going to be needed. One example is Stargate, which is actually a project that has been out there by OpenAI initiative, and it is aiming to build a $100 billion supercomputer project, which is composed of hundreds of thousands of GPUs, and the initial phase, which is supposed to complete in this year, is 64,000 NVIDIA GPUs that are going to be placed into this. I would like to mention that these GPUs that they want to put into 64,000 is going to be $50,000 per each. So it's like you're having $3 billion, dollars for the GPU equipment that's going to go into this initial phase of the project. And obviously that goes with additional equipment, not only the GPUs that you want to buy, but also you have to invest in the infrastructure, electricity grid, network, and other components. Another thing that we need to mention here is, besides from these infrastructure implementations, the hyperscalers, as we name them, Amazon, Google, Meta, and others, are now becoming the AI giants, right? And they not only generate and use data, but also they house hardware and they try to build their own hardware. In addition to these GPUs, for example, NVIDIA is building, they're trying to manufacture their own hardware equipment, custom equipment to support their AI needs, and also they need energy to run their hardware systems. So just wanted to emphasize the ChatGPT model's GPU numbers here. As you can see, it is again in the 100,000 plus GPUs that are being used as part of the hardware for training these latest AI infrastructures. Again, the cost of using and running these infrastructures is not cheap. So it's just showing you the generation of the latest GPUs. The one on the last row that you can see is a 50K, latest NVIDIA GPU, and putting such a box here on the right-hand side, the picture that you can see, which is DGX B200 box, is actually costing you $500,000. Just 8 such boxes of GPU. So that's essentially the cost that you need to pay for setting up an infrastructure that you can train the whole system. And also, I wanted to mention the setup cost range. So there are cheaper versions that you can target. Whether this is the true data or not is another question, because some people believe that DeepSeek values are not really the correct values that they report. So it can be taken with a question mark, but you can also consider Grok numbers with a question mark as well. But that's something to keep in mind. As you can see, the range is millions of dollars versus billions of dollars. So the range is quite high, and maybe you can go with the smaller scale implementation, smaller scale setup according to your needs. So one distinction that could be implemented as part of the designs is pre-training versus post-training. Pre-training is GPT-5 versions of models that you train first, and post-training is actually you take a model that has been already trained and then post-train it accordingly. So this could be done with a precision expert cost, and you can actually improve your design. And actually there's a multifold improvement that you can get with such implementations. So I'm going to just mention the Stargate implementation. So you see a lot of buildings that are being built as part of this infrastructure. So they have huge facilities that they are building for this $100 billion project. Just by itself is costing budgets of many countries altogether. So that's something to keep in mind. One last part of my talk, actually this is the most important part, but I think I'm out of time now. The basic hardware needs that you have is the silicon, and that is actually TSMC is the foundry king which develops the chips. So 90% of the high quality chips get out from TSMC, Taiwan Semiconductor Manufacturing Company. So you have this giant that you need to deal with, and then custom ASICs which are implemented by these AI companies like, for example, Amazon, right? So they build their own chips accordingly. So we have fabless designers who do not have fabrication facilities, but they just design, architect, and send it off to TSMC to build the chips. So fabless, so I'm not going to go over these, but we have the different infrastructure in chip industry that you need to consider while dealing with the AI industry and AI chips accordingly. And we actually need to also consider the TSMC as a key player in the whole thing. And Intel versus TSMC, if you look at numbers, they have actually 10 times more chips that they're developing compared to TSMC. So maybe just to mention that you need to have $15 to $30 billion to create a fabrication facility for a chip company. So that's a huge investment that you need to have. US already has been investing in this just to get things avoiding from China so they can put it into their mainland instead of relying on Taiwan. They want to actually move things into their own local resources. So final thing here, what do we need? We need the ultimate triangle is power, data, and silicon. So you need the power, energy to run, data to use in that data center, and then also the silicon to run these in an efficient manner. So thank you for listening.
Thank you very much, Professor Öztürk. I would like to invite Professor Muzaffer Elmas to the stage. He will present as the last presentation of today's session an interesting case study conducted at Kocaeli Health and Technology University. Let me briefly introduce you Professor Muzaffer Elmas. He is a Turkish academic specializing in civil engineering. Professor Elmas is a member of Afa's Earthquake Advisory Board, the Council of Higher Education's Vocational Qualifications Institution, and a full member of Tüba. Since 2022, he has served as Rector of Kocaeli University of Health and Technology. The floor is yours, Professor Elmas.
Thank you. My presentation, okay. My presentation, I have supported education and accreditation management in higher education. Connection. Okay. Click. No. And my presentation is two parts. And firstly, I talk about theoretical things about changing in the world. And second part, we developed a web page education, AI-supported education system. That 6 way of innovation. And before AI and big data, and water power, steam, and antibiotic, electronics, ICT, internet, and developed changing a linear, but IA changing and logarithmic. University, this way, a very hard way, and university and digital area. And there are no paid and now complex and irregular part. Wow. Everything in education, in social, in economy, in things. We talk about 10 and 15 years and universities and future universities, future department, future skills, future competence. But I think the future has arrived. This sentence for me, ne Muzaffer Elmas. I talked 2 years ago. What we need to do is understand the creative change is leading and adapting. You know our technology change curve, human harmony, and artificial intelligence, flexible education, microcredit instead of diploma, and flexible policy, strategic management instead of, and continuous monitoring instead of accreditation. This picture explained at Stanford last month. Every year explain this monitor. This artificial intelligence is approach human level capabilities in areas such as image recognition and language understanding. Classic exams are becoming insufficient. Grades and are gradually losing their meaning. Academic integrity must be redefined. Universities must redesign themselves in terms of curriculum assessment and evaluation and accreditation system. The problem is no longer what artificial intelligence can do. It is how quickly universities can adapt to this new reality. Flexible education model, microcredit dental and certificate programs, and artificial intelligence courses and applications, and industry-supported projects during undergraduate education. How to find a way forward in such a rapidly changing and complex stage? We leaders and rectors, dean, and everybody, let's reshape the university with IA and microcredit dental. Academician against to change. For example, I tested and it turned out incoherent due to the hallucination and a lack of clear ethics and compliance guidelines. But we enable change, we a simple system set up after that against change and reduce. We developed, before presenters explained everything, but we developed our powered higher education management system, web-page system, update lesson plan, update courses, alignment learning outcomes, resources, and assessment strategy, integrating of tools and others, incorporation relevant content where appreciated. Our system level in, but I explained it our web page before. Okay. Our web page was Turkish, but translate into English. Hocam, ben bir şey yapmadım ama ben bir şey yapmadım. Bununla bir ilgisi var mı? Yok. Yine ne? Yeah. Our system at Turkish, but translate and Google. Firstly, academician and click this page and choose courses. I choose any courses. And analyze this syllabus. Update academician and automatically come from information packet and Bologna process information system directly and course syllabus. Course syllabus analyze and in the universities level and in the world changing about prompt. Yeah, please wait. And internet in there are not good. Yeah. For example, these courses and much rate 80%, and this the census score and 710. Before these courses, this syllabus and analyze results, and these courses strengths and suggest and detailed analysis and areas improvement and suggest. This system worked about Gemini. Gemini. If you want academician change our syllabus and course content and course learning outcomes, and if you want change, and click this and academician syllabus. If you want course objective and if you want artificial intelligence proposal, and click this wait 1 minute. Vaktim var değil mi? Böyle çok da sorun yok.
Hocam 10 dakika.
Ha, tamam. Good. Wait. This, if you want academician changing course objective and artificial intelligence working and continue course content if you want changing the course content, and if you want other things, it is very important is course learning outcomes, program learning outcomes connected. Very important is. Many academician is not good is connection, but IA click this inshallah click. Yeah. Yes. IA proposal and course objective. Academician read this if you want to change course objective and click changing. Click. Okay. And course objective and program learning outcomes relationship, artificial intelligence working. Many universities, many departments, this syllabus not update, and 2 years, 5 years, many years, but yeah, recommended and click course learning outcomes and program learning outcomes, and change this table and contribution, connect to each other. If you change anything, it is changed in everywhere, and course catalogs and course thinking and program learning outcomes, course learning outcome matrix, changing everything. If you want any course lecture notice, click. Very easy. Click. Academician work this system beginning of semester, about 10 years, 10 days, and update our courses. After that, per lesson, beginning of lesson, and click, choose, and courses, and choose a week. For example, and automatically coming and course material, this. Before students working this material, if you want and notebook LM, I think very user-friendly system. Students and video and podcast and anything work before. Academician, firstly, in the, for example, 3 hours lesson, about maximum 20 minutes explain course theoretical things. Maximum 20 minutes. After that, and click this study topics, click, and I created about nine different study topics. Academician, after 20 minutes theoretical and implementation, about 80 and 90 minutes for critical thinking and group working and in everything and active learning students and academicians. And create. Bir iki dakika bana şey verirsin. Bak internetten dolayı. Yoksa benden dolayı değil.
Can other universities use this? Or
Yeah, our university use.
other universities?
No.
Başka üniversitelerde
No. I use first semester in our university use, and after that, yeah.
So you can also outsource to give to some other one? Other universities.
Next time, inshallah.
Free or paid.
I don't know. If you want academician and sorry and 4 minutes.
He's running out of time. Okay.
Study topics, and if you want academician, everything managed academician, everything. Editing is, if you want these topics and change question and manual editing, this manage academician, this system. After that, create a end of lesson, create of quiz, short exam, course end of lesson, and choose question and 5 questions and topics. If you want, create a short quiz and 1 minute for internet.
Okay.
Addition instruction. If you want academician, addition prompt this click. For example, this issue very important is things. But this system is very simple and user-friendly system. Quiz created. Bundan sonra toparlayacağım.
Okay. We are
Yes.
waiting for the quiz, right?
Yeah. İnternet. But this quiz, no, internet, it is problem, but create a quiz. Okay, olsun. In this system, integrate this system, facilities course update to ensure alignment between course and program learning outcomes, foster a learning process that develops reasoning, analytic thinking, and critical thinking, rather simply transfer information. As a result of accreditation process, become more efficient. Internet, yeah. Yeah, okay. And these courses, 5 questions, but if you want academician editing this, make it harder and change question and manual edit. Very, and this writing before, because and per question connect to course learning outcomes and program learning outcomes. Connect, and 1 minute.
Okay.
Hocam internet olsa çabuk olacaktı ama. Yeah. Yeah. For example, this problem and program course learning outcomes 1, course learning outcomes 2, question for course learning outcomes 2 and 3, program learning outcomes connect. After that, and download this course, answer students, and midterm exam, and create an assignment and every courses. And after midterm exam, analyze before things and course and midterm exam and assessment and quiz and others, personal individual learning management after that. Because students and score high and level for this end of semester and analyze this system and program course learning outcomes score average and program learning outcomes scores, and click this any students and students program learning outcomes score and course learning outcomes score. After that, yeah. Accreditation, many accreditation connect to learning outcomes. Accreditation system, heart of accreditation is learning outcomes. But we explain these learning outcomes, and accreditation is very easy. And accreditation traditional approach, and is there a course syllabus? But now our course outcomes truly measured, and was an exam conducted, which learning outcomes did the exam measure, and did the instructor, and from traditional approach and new approach, only an output, not input. Because in this system, an accreditation is very easy. You know this picture? The last picture. Thank you. Çok
Okay,
az.
thank you very much. Thank you very much, Professor Elmas. Now it's time to get questions. Yes, please.
I'd like to have a question for Professor Öztürk. So for the pyramid that you have presented for the GPU design and building that AI is inevitable for the near future, what if you engage the place of in that pyramid?
I will open up the prep. Okay, so the question was where should Turkey be in that pyramid that I kind of put up there? Yes. Mhm. So I had to go through that slide really fast, although it was one of the most important part of the presentation. So. Şurada slide gösterisi diyeceğiz hocam. Okay, so I guess it's up there.
Noktadan ilerletebiliriz hocam.
So this is the triangle or the hierarchy. As I couldn't explain it well, the lowest level is the design tool industry, which actually has the software to develop for hardware development. And then the level above is wafer fab equipment, which actually creates, designs the fabrication equipment that will be used in the manufacturing facilities of chips. As you can see, there's a company called ASML there, which is one of the many companies that lots of Aselsan engineers actually went into working for. So they develop, the fab facilities, and they're, in Netherlands. And then you see fabless companies, NVIDIA, IBM, AMD, ARM, Apple, Qualcomm. These are all fabless companies which do not have a fab to develop. They just use TSMC facilities, Taiwan facilities, and then up you have the chip foundries. If we target chip foundry, this is going to be very expensive, and as you have seen, lots of money needs to go into this, and then the longevity of such facilities is not that long. So after 2-4 years, you have to reiterate and go and create a new fab, new billion-dollar investment, which is highly expensive when you consider the limits of Turkey right now. So I think the best option would be to go for companies that actually may be in the fabless domain. So that would be the possible area where we can architect our own designs, our own chips, using mainly open source tool sets like RISC-V, and then create and fab based implementations for those chip foundries. So I think that would be the best option.
But are you also able to design GPUs, not maybe close to NVIDIA, but GPUs that can do tasks for us?
Actually, in terms of design, chip design, overall CPU, GPU, custom hardware, there are not many companies or research institutes, so it's not a lot that we have in terms of manpower. And the ones who actually are well in this area usually go to overseas or Europe for working, because there are not enough companies that will be supporting such workforce. So I think definitely that's an area that we can invest easily in terms of funding that might be needed for that. But there's a lot of way there to go, I guess. Thank you.
Thank you. Any other questions for any of the presenters? It seems there are no. Yes, please.
One thing is we all talk about but it's always given as a standalone number. I guess maybe just a suggestion, as a comparison, maybe like we can tell how much electrical car consumes, or the number of electrical cars consuming the energy compared to GPUs. I don't know, at least, you know, like we have to see some sort of reference to see, I don't know, are you comparing like GPUs to my phone? I mean, of course,
Of course not, but it's a huge energy consumer. Maybe I should have put a slide that kind of shows it with a country, for example. I had a slide back in another presentation, but not in this one, but yeah, you're right, maybe it's putting it in a better perspective for the listener, yeah.
because electrical cars would be a good,
Yeah, I would guess,
I'm
but
not saying anything about it.
Yeah.
I'm saying things about
Yes.
AI.
yeah, I would guess, but I'm not sure about the numbers. Thank you.
Okay, thank you very much for questions and answers. And I would like to invite Professor Lee to the stage to present the presenter's certificates of attendance. Okay.
Hocam.